Hey everyone, and welcome. Today, we're diving into something pretty wild called SAFErGrid. It's a proposal that suggests we need to rethink our entire electric grid from the ground up. But let's start with a question that might sound a little crazy. You know how we're all pushing for a green energy future, right? More solar panels, more wind turbines. But what if that very transition, the thing that's supposed to save us, could actually be the thing that breaks our century-old power grid? Because honestly, that points to a very real problem. Our current grid, which was an absolute marvel of engineering for its time, is really being pushed to its limit. So here's the conflict at the heart of it all. The old grid was designed for these massive, centralized fossil fuel plants. Their giant, spinning turbines provided something called physical inertia. You can think of it like a massive shock absorber, just constantly smoothing things out and keeping the grid stable. But renewables, like solar and wind, they feed power into the grid using electronic inverters. There are no huge moving parts, which means, you guessed it, zero inertia. And this is the key. The very thing that made our grid so reliable, this perfect continent-wide synchronization, is now becoming its biggest weakness. And listen, this is not some far-off what-if scenario. We are already seeing the cracks form. Back in 2016, a huge blackout hit southern Australia. In 2021, a tiny fault in Croatia almost took down the entire European system. And even more recently, a blackout in Spain and Portugal just drove the point home. The system is becoming fragile. So what do we do? Well, the researchers behind the SAFErGrid idea looked for inspiration in a really surprising place, the complete paradigm shift that gave us the internet. Just think about it for a second. The old telephone network was a lot like our grid today. Very rigid, very synchronous. To make a call, you needed an actual, dedicated, unbroken physical line connecting you to the person on the other end. The internet completely blew that up. It brought in this flexible, asynchronous system that chops data into tiny little packets, sends them all on their own independent paths, and then just reassembles them on the other side. It's a totally different way of thinking. And that brings us to the core of the whole proposal. The researchers basically asked, what if we did the exact same thing for energy? What if we just abandoned the principle of perfect, rigid synchronicity that's causing all these problems? And that, right there, is the revolutionary idea behind SAFErGrid. So how in the world would that actually work? Let's take a look at the blueprint. The fundamental building block for this whole new system is something they call an A grid. The A stands for asynchronous. The easiest way to think of it is like a little local energy neighborhood. It could be a city block, a factory, or even a housing development that can manage its own power, totally independent of the main grid. So the big idea here is to break our one single gigantic grid into a huge network of these smaller independent A-grids. So instead of one massive fragile system, you get thousands of them, each one resilient and able to stand on its own. Okay, but if they're all independent, how do they actually work together? Well, this is where that analogy to the internet gets really, really powerful. You see, these A-grids would be connected by brand new devices called energy routers. And they do pretty much what you'd think. Just like a data router sends your emails and videos to the right place, these energy routers would manage the flow of power between all the different A-grids, using a similar store and forward idea. But of course, energy isn't exactly like data, right? You can't just copy and paste an electron. So the way this energy gets managed is absolutely crucial. The system follows a set of priorities they call AFSC. First, energy is aggregated locally. The system's #1 priority is to forward it to a neighbor that needs it. If that can't happen, it gets stored, maybe in some local batteries. And only as the very last resort is it converted into something else, like hydrogen. It's a really smart, dynamic way to manage energy flow. Now, this whole plan isn't just about making the grid more stable. By changing the deep-down architecture, SAFErGrid could actually unleash a whole new ecosystem of innovation. Think about how the internet works in layers. You've got the physical fiber optic cables at the bottom, then the routing protocols, and then way up top, the apps on your phone. SAFErGrid proposes the same thing for energy. And this separation is a huge deal because it means you can innovate on the top layers, creating new services and apps without having to completely rebuild the physical grid every single time. And that is where things get really exciting. It could create a whole new digital economy for energy. Imagine paying for electricity with a flat rate plan, just like your internet bill. Or picture a smart dishwasher that automatically negotiates with the grid to run when power is cheapest. People with electric cars could actually become players in the market, selling power from their car batteries back to their local grid when demand is high. It could even create whole new types of businesses, like energy delivery networks, basically acting as marketplaces for electricity. Now, this all sounds pretty amazing, but let's be real, it is a massive undertaking. So let's talk about what the path forward actually looks like. And the researchers are upfront about this. The single biggest challenge is scale. Taking these decentralized ideas and applying them to an entire continental grid, like all of Europe, that is a monumental task. But that is the ultimate goal. But here is one of the most brilliant parts of the whole plan. We don't have to flip some giant switch overnight. SAFErGrid is designed to be rolled out incrementally. We could start by building one A grid, then another, connecting them piece by piece. The new system can literally grow up inside and alongside the old one, which makes the whole transition actually seem practical and manageable. And while this is definitely a bold, high-risk concept, it's got some serious muscle behind it. The research is being funded by a super prestigious ERC Synergy grant from the European Commission, and those grants are specifically for ambitious, high-risk, high-reward projects that could truly change our world. So it all leaves us with one last big question to think about. As we push forward into a future that's going to be powered by renewables, could this be it? Could this internet-inspired blueprint, this vision of a decentralized, asynchronous, and innovative network be the key to building a grid that's not just stable, but also smarter and more open than anything we've ever had before?